Hi guys, and welcome to Cons tutorial. Today we will be talking about the evolution of operating system. In the previous video we have been talking about evolution of operating systems, where we spoke about serial processing system, batch processing system, multi-programming system, time sharing system, personal computer system, parallel system, distributed system, and network operating system. So in this video we will round up by talking about real-time system. So let's get started. Real-time operating system. A real-time operating system is an operating system for real-time applications that processes data and events that have critically defined time and constraint. So when we talk about the real-time operating system, the real-time operating system is a kind of operating system which concentrates more on real-time applications. That is, it processes data and events that have critically defined time constraint. Like for example, we can take the Tesla self-driving cars. These self-driving cars have to take photos and process these photos in order to know the route to take. So these processes need to be fast so that the application can be able to make the right decision for these cars to move smoothly on the way. So we will see that in a real-time operating system, it is more important for the system to respond quickly rather than manage the resources efficiently. So in a real-time operating system, the resources of a real-time operating system are often heavily underutilized. This is because it is more important for such system to respond quickly rather than use their resources efficiently. So some of the points to note about real-time operating system. First, the real-time operating system are used in environments where a large number of extreme events must be processed in a short time or within a certain limit by the computer system. Like the example I used, the Tesla self-driving cars. While these cars are moving on the way, the cars needs to take photos and the system needs to process these photos in order to be able to control the car efficiently. So this is an example of a real-time application. So real-time operating systems are used in environments where a large number of external events must be processed in a short time or within a certain limit by the computer system. Another point to note about the real-time operating system is a real-time operating system must have well-defined fixed time constraint. The job on hand must be processed within the defined time constraint or the system will fail. Like for example, in an industry, a petrol industry, there might be an application which has to determine when the pipes are overheated. So this is very important for the results to be out, for the results to be known very fast, so that measures can be taken to cool down these pipes. If not, it might lead to a very dangerous situation. So a real-time system must have well-defined fixed time constraint. The job on hand must be processed within a defined time constraint or the system will fail. And a good example too is still the Tesla car, the self-driving cars. Like take for example the self-driving car driving in a city with people crossing the roads and all the like. So the system has to be able to process these photos really fast in order to be able to take the right decision. The next point to note about real-time operating system is that here each process is assigned priority depending on the relative importance of the event being processed. So the events being processed are based on priorities. So the high priority processes are being processed first. An example, we have a measurement of a petroleum refinery indicating that temperatures are too high might demand immediate attention to avert an explosion. So that is an example of a situation where a real-time operating system is really needed, because if any time is being wasted, this can lead to an explosion. So a measurement from a petroleum refinery indicating that temperatures are too high might demand immediate attention to avoid explosion. So this will also mean that there needs to be a time constraint for the application to process and reach out with the results, so measures can be taken faster. So examples of real-time operating systems: we have medical imaging systems, we have industrial control, we have flight control, we have simulations, we have military applications, we have ocean shipping and tracking. So in medical systems, we know, like the hybrid machine where they checks the heart rate of a patient on coma. We have industrial control, like the example we just used here about the petroleum refinery in order to avoid explosion. We have flight control, we have simulations, we have military application, we have ocean shipping and tracking. This is important. This is also important when people have to track their when the post, when your goods are being sent to you and you have to track them. It's also very important. And so now we are going to talk about the three main characteristics of real-time operating system. So as we all know, real-time operating system has three main characteristics, and these characteristics, the first will be about memory management. So when we talk about memory management here, memory management is not so important, since most of the time processing remains in the main memory to provide quick response. However, they do provide protection and sharing of memory. Another characteristic of a real-time operating system is input-output management. One of the main characteristics of a real-time system is time-bound device management. However, they do provide interrupt management and input-output buffering. So the next characteristic is file management. The speed of file access is very important in a real-time operating system. So when file management is provided in real-time operating system, it must satisfy the requirements. In fact, some real-time systems do not have secondary memory, which is very important, since there is a time constraint and the result is needed faster. So some real-time systems do not have secondary memory. So in this case, it is important for the files to be available in the main memory so the processing can be faster. So we see here the three main characteristics of a real-time operating system. We have the first will be about memory management, where we get to know that memory management is not so important, since most of the time processing remains in the main memory to provide quick response. And we also have input-output management, and we have file management. Next is we will talk about the advantage of real-time operating system. In a real-time operating system, one of the advantage of real-time operating system is that memory management is less demanding. So while dealing with the real-time operating system, the programmers do not really concern more about memory management, since most of the applications need to be present in the main memory so the processing can be faster. So memory management is less demanding. And the second advantage here in the real-time operating system is that it provides interrupt and input-output management. So there is management for interrupt and input-output management. Another advantage of real-time operating system is file management speeds up the access of files, and also resource management is less important in a real-time operating system. In as much as it has these advantages, we also have two main disadvantages. The first is time limit is allotted for every event, which means if this event go beyond this time limits, the results might be the after effect might be dangerous. So it is very important for the applications to keep to the time limit. So a disadvantage is time limit allotted for every event, and also costly implementation is another disadvantage. The real-time operating system is costly to implement, since we know main memory is always more expensive than secondary memory. So thank you for